back, students. Now we have some knowledge on, actually we already on discuss on centrifugal type of compressor, reciprocating compressors, what are the minimum work done required for reciprocating compressor or different compression processes, okay, and what is the performance characteristic, what is multi-stage compression, and what is clearance volume, what is volumetric efficiency. Actually we already cover on these topics. Now let's take a numerical. In this numerical, actually it gives the numerical is the water is used to a standard single stage VCR system. The system is operates an evaporator temperature of 4.5 degrees Celsius. So the data are already given, so go through this problem first. What are the value are given. Now what you see that in this problem, and you have to calculate, actually you have to calculate the COP and the volumetric refrigeration effect. So first of all, water is used at a standard single stage VCR system. The system operates an evaporator temperature, so that means evaporator temperature is TE is given, so that is actually given here study material, you can go through it. So evaporator temperature TE is given 4.5 degrees Celsius is your evaporator temperature, okay. Now corresponding evaporator temperature in the numerical, that pressure is given, that is 0.8424 kilopascal, okay, and condenser temperature for the system is given that 38 degrees Celsius. That now condenser temperature is somehow it indicate capital T suffix C, that temperature is 38 degrees Celsius, that is 311 Kelvin, 311 Kelvin, and corresponding pressure is given that 6.624 kilopascal. The corresponding pressure is also given, that is 6.624, and assume that the water vapor behaves as an ideal gas. So it behaves as an ideal gas, okay, and with gamma, that is basically specific heat ratio, that is Cp by Cv, that value is 1.322 is given, okay. And the now you have to calculate the discharge temperature of the compressor, sorry, of the compressions is isentropic, also calculate. So discharge temperature is basically TD, you have to calculate discharge temperature of the compressors, and you have to calculate the work of compressions. Next you have to calculate the work of compressions, okay, work of compressions. Now also calculate the COP and the volumetric refrigerant effect, and if the refrigeration effect is 2355 kilojoule per kg, okay, and there are some value are given, that molecular weight and universal gas constant, all these terms. Now as you know that basically that gas constant is basically capital R, which is basically the gas constant value, that is 8.314 divided by 18, because of molecular weight of water is given 18 kilojoule per kg mole, and 8.314 is basically universal gas constant. So R is equal to, so universal gas constant value is given, so you can get the value of gas constant value for water, okay. So gas constant value for R is universal gas constant divided by molecular weight of the water, that is 0.462 kilojoule per kg Kelvin. Now specific volume of refrigerant at the compressor inlet, specific volume of vapor refrigerant inlet is basically, you know that it follows the ideal gas equation. So PE into VE, that is equal to RT, okay. So VE basically specific volume of refrigerant at the compressor inlet, that is basically RTE by PE. So V is equal to RT by PE. So put these values, R is equal to 0.462 here, TE, that is basically 4.5 degrees Celsius, okay, and by PE, now 0.8424 kilopascal, okay. You can get the value of 152.19 meter cube per kg. And the discharge temperature TD, you know that the TD basically is a isentropic process, and for the temperature pressure relationship for the polytropic process, or you can say that the adiabatic isentropic process is that T2 by T1. You know that if the process is from process 1 to 2, you can get the value P2 by P1 gamma by 1 by gamma. Now in this case, so again TD by, in terms of T2 here, TD by TE, so this is the inlet condition, this is the exit or discharge condition, is equal to, okay, this is the exit conditions. Now this is PC by PE. So PC by PE, or you can say PD by PE, whatever you are. So PC by PE. So TD is equal to TE into PC by PE. Okay. Okay. PC by PE. So from that equation you can calculate the discharge temperatures. So you can, if you get values, all these values, you can already get these values from the numericals. PC is your 6.624 kilopascal. PE is your the value of PE is given your 0.848424. So put these values, you can get the value. Now work of compressions. Work of compression expressions already we have come to the from the performance of reciprocating compressors or work done required for the compression processes. From that equations you can required work done for the compressions you can get. So RT means PV, that is the main expression is you can, so PV by gamma minus 1, okay, into P2 by P1 by to the power gamma minus 1 minus gamma minus 1. Okay, so in terms of PV you can write down RT here, so gamma by gamma minus 1, so PC by PE to the power gamma minus 1 by gamma minus 1. So this is a final expression that the work done required for the compressions. Now you can write down this equation for the work of compression, that is RTE gamma by gamma minus 1 into PC by PE to the power gamma minus 1 by gamma minus of 1. Already you have all these values, you already known to you that value of RT gamma is 1.3, TE basically 277.5 Kelvin, R is 0.462 kilojoule per kg, PC is given, that is basically 6.624 kilopascal, PE value is given 0.8424. so all this value is known to you, that after calculation you can get the value of required work for compressions. Now as you see the COP is the refrigerant effect, so refrigerant effect divided by required work done process, work for compressions. So QC is the QE basically given, so QE 2355 kilojoule per kg, 2355 kilojoule per kg is given is your numerical. The refrigerant effect that given is your refrigerant effect. Refrigerant effect is 2355 kilojoule per kg. Write in this equation in terms of QE here, and WC 343.65. Then you can get the value of COP. Now QV. Also calculate the COP and volumetric refrigerant effect. Now this is the COP. Now you have to calculate the volumetric refrigerant effect. That means volumetric, you know that the value of QE means refrigerant effect, that is given as 2355 kilojoule per kg, and VE means VE, small VE, the specific volume of refrigerant, that is basically 152.19. If you get 2355 by 1 specific volume of vapor refrigerant, now this value 152, if you divide on this you can get the value of volumetric refrigerant. Okay, volumetric, also calculate the volumetric refrigerant. So this is your refrigerant effect, so this is the refrigerant effect 2355 kilojoule per kg. Now just it converted to volumetric, so volumetric means divided by specific volume of refrigerant at the compressor inlet. If you divide onto this, you can get the value of QV. That means 2355 is given is refrigerant effect divided by 152.19. So this is your refrigerant, this is your actually specific volume of refrigerant at the compressor inlet. So first go through the problem, what are the value are given, then you just solve it. Okay, thank you very much for listening me and watching me. Goodbye.